Hello everyone. This video would focus on graphing cube root equation in vertex form, and this is the first part. In this part, our value of a would be positive 1 for this, and in the second example, we're going to have a negative 1. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to cube root equation in vertex form. Before we jump into this example right here, let's have a review on the basics of cube root equation in vertex form. We remember that the graphing form or the vertex form of a cube root equation is given in an equation y equals a cube root of x minus h plus k. Now let's investigate the effects of a, h, and k to the graph. Now we remember that if a is positive, one of the two branches rises to the right. So as you can see here, this end of the graph rises to the right. Now if we change the value of a to 0, so please notice that if a is 0, I'm changing the value to 0 right now. If a is 0, the graph is a horizontal line. So as you can see here, the graph is a horizontal line. On the other hand, if a is negative, one of the branches, there are two branches, so one of the branches is falling to the right. So this side right here is falling to the right. Again, that if our a is negative. On the other hand, the closer the value of a is to 0, as you can see here, we started from negative 10. We're making it closer to 0. We're moving it all the way down to 0. You can see that the graph is horizontally compressed. So until to such a point that if a is 0, the graph is totally compressed, forming a horizontal line. And that is also the same thing on the other side. So starting from the value of a, which is 10, once it goes to 0 or the graph gets closer to 0, the graph again becomes horizontally compressed. That means the graph becomes more horizontal in shape. So it is horizontally compressed. On the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means on the contrary, the farther the value of a is from 0, that means from 0 we go higher value all the way to 10, the more that it is vertically stretched. So as you can see, it becomes more vertical as we go farther from 0. And that is also the same thing for the other side. So you start from 0, we go away from 0 towards negative 10. Again, the graph will become vertically stretched. That means its shape becomes more vertical. Now, we also remember that the coordinates h, k is the vertex of the graph, or we call this as the locator point, where our h translates the graph left or right, and our k translates the graph up or down. So these are the basic information about the graph of a cube root equation. Okay, so we go over the problem here. The first step in order that we can sketch the graph for this is to determine the vertex or the locator point. I'm going to go ahead and write that down here. We remember that the coordinate of the vertex or the locator point is hk, and these are the values that corresponds to hk. The trick is, in order that we can determine the the coordinate of the vertex, is we switch the sign of this. So that would be a positive 2, and that's a positive 1. So we switch and keep. So this is where the vertex is gonna sit. The second step is to create and complete the table of values. So I'm gonna go ahead and draw the table of values down here. Okay, the numbers that we write on this table of values, we will start from the vertex. So we're going to put it in the middle. So this is going to be 2 and 1. Then we can do more numbers here to complete the x values. So we can have 3 and 4. We go the other way. That would be 1 and 0, so that we go ahead and determine these numbers, these y values that we have here, which are actually blanks. So what are we going to do in order that we can determine those values for y is to use the x value here and we plug it into the equation. So for example, I'm going to have the value of y when x is 1. So what I would do is I will plug that in here, so the equation would come out. Okay, so what we would do is, instead of writing x, I left it blank because that's the number that we put in there. So I'm going to have 1 right there, so that we go ahead and simplify this. This would come out the cube root of 1 minus 2 is negative 1. So I'm going to write negative 1 right here. And then that's a plus 1. So this is cube root, by the way. The cube root of negative 1 is negative 1. And then we have a plus 1 right there. So this tells us that our value for y when x is 1 is 0. So I'm going to go ahead and write that down here. So I will show the work for 3 here. I will put that here. So that means x is equal to 3. And I will plug the 3 into the equation right here. So this is going to come out. Okay, so the value that I got here is 2, because we have 3 minus 2 is 1, and then the cube root of 1 is 1, and then we have a plus 1, so 1 plus 1 is 2. Now what are we going to do is I will show the work for y when x is 0 and y when x is 4 on the side down here. Okay, so this is the table that we're going to use in order that we can graph this equation right here. And these are the work that we have here. So the next step is to sketch the graph of this equation. So we're going to start with the locator point that's going to be on 2 and 1. So this is our first dot. And we have 3 and 2. So 1, 2, 3. Then we go up 2. And then we also have 4 is to 2.26. So 1, 2, 3, 4. 1, 2, 2.26 should be somewhere around here. And then we go the other way. 1 is 0. And then we have 0 is negative 0.26. So that should be somewhere around here. So we go ahead and sketch the graph. Okay, if you notice, the graph infinitely goes towards the right and infinitely goes towards the left. This tells us that our domain would be all real numbers. At the same time, this is going up infinitely and this is going down infinitely, so that means our range would also be all real numbers. So I'm going to go ahead and write that up here. Okay, now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. The first step, again, is to determine the locator point. I'm going to go ahead and write that down here. Okay, our vertex or locator point here is -2, -4. Because remember, we're supposed to switch this positive. It came out -2. And we keep, that would be a -4. The second step is to create and complete the table of values. So I'm going to go ahead and draw the table of values down here. Okay, so what I did here was I wrote the vertex or locator point in the middle of these blank boxes, and then I determined the rest of the values. So I went up -2, -1, 0. I went the other way, -3 and -4. Our next step is to determine the values for the rest of these blank cells here using the value of x that we got on the right side of each blank, and then we plug this x into the equation and then we solve for y. So I'm going to go ahead and show the work on the side right here. Okay, so we got these two values here. Now notice this very carefully. We have negative 1 plus 2 is positive 1. The cube root of positive 1 is 1. And then we have a negative in front. So negative of a positive 1 is negative 1. And then we have a negative 4. So we came out negative 5. Or we can actually rewrite it this way. That would be negative that's negative 1 minus 4. We still have a negative 5. So either of those would still be right. And then for this one right here, negative 3 plus 2 is negative 1. The cube root of negative 1 is negative 1. So negative over negative is a positive. Minus 4 is negative 3. I'm going to go ahead and show the work for x is 0 and x is negative 4 down here. Okay, so these are the values on the table that will be needed in order that we can graph this equation right here. So the next step is to sketch the graph. So we're going to start with the vertex. Negative 2 goes to negative 4, so it's going to go down here. And then we also have negative 1 goes with negative 5, so it's going to go down here. And then 0 goes to negative 5.26, so that should be somewhere around here. And then we have negative 3 goes with negative 3. So that's 1, 2, 3. And then we have negative 4 goes with negative 2.74. So that would be 1, 2, 2.74 should be somewhere around here. And so we can go ahead and sketch the graph. Now, please notice that this graph is going to go to the left infinitely, and this one is directed to the to the right infinitely. And at the same time, it's going up infinitely and it's going down infinitely, which means that the domain and range for this would be all real numbers. So I'm going to go ahead and write that up here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!